Moving on to the first question. State which of the pair of triangles in figure 6.34 are similar. Write the similarity criterion used by you for answering the question, and also write the pair of similar triangles in the symbolic form. Now moving on to the solution. Let us consider the two triangles in the first bit. Here angle A in the first triangle is equal to angle P in the second triangle PQR, and also angle B is equal to angle Q and angle C is equal to angle R. Now in these two triangles, according to AA similarity, as all three angles are equal, we can say triangle ABC is similar to triangle PQR. Now moving on to the solution for second bit of first problem. Here let us take the ratio of sides, that is consider AB by QR, that will be equal to 2 by 4, which is nothing but 1 by 2. And in the second case, let us consider BC by PR, which will be equal to 2.5 by 5, that is nothing but 1 by 2 again. And finally let us consider the ratio of AC by PQ, which is nothing but 3 by 6, that is equal to half. So as all the ratio of sides, that is the ratio of corresponding sides, that is AB by QR is equal to BC by PR is equal to AC by PQ. So finally we can say that triangle ABC is similar to triangle A corresponds to Q and B corresponds to R and C corresponds to P. Finally we can say that triangle ABC is similar to triangle QRP according to SSS similarity, as all sides correspondingly are in proportion. Now moving on to the solution for third bit. Let us consider the ratio of sides, that is MP by DE, which is equal to 2 by 4, that is 1 by 2. And also if we consider the ratio of sides, that is LP by DF, which is equal to 3 by 6, nothing but half. And here LM by EF is equal to 2.7 by 5. Here only two corresponding sides ratio is in proportion. So we can say that the given triangles are not similar. Now moving on to the solution for fourth bit. In triangle LMN and PQR, angle M is equal to angle Q is equal to 70 degrees and MN by QR is equal to 2.5 by 10, which is nothing but 1 by 4. And here ML by PQ is equal to 5 by 6. Here angle is equal, but corresponding sides, none of them are in proportion. So we can say that the given triangles are not similar. Now moving on to the solution for fifth bit of first problem. Here angle A is equal to angle F is equal to 80 degrees and AB by DF is equal to 2.5 by 5, which is nothing but 1 by 2, and also BC by EF is equal to 3 by 6, which is 1 by 2. Therefore AB by DF is equal to BC by EF. Here the corresponding angles is equal and the two of the corresponding sides are in proportion. So by SAS similarity we can say that triangle ABC is similar to triangle FED. Now moving on to a solution for 6th bit. Here two angles of a triangle are given, that is angle D is equal to 70 degrees and angle E is equal to 80 degrees. Let us find angle F. We know that sum of angles in a triangle is 180 degrees. Here F will be equal to 180 minus 70 degrees plus 80 degrees, which is nothing but 30 degrees. So here we got F as 30 degrees. And in triangle PQR, we know that sum of angles is equal to 180 degrees. He has given the angles Q and R. So let us find angle P is equal to 180 degrees minus sum of two angles, that is 80 degrees plus 30 degrees, which is nothing but 70 degrees. So here we got angle P as 70 degrees. In these two triangles, angle D is equal to angle P and angle E is equal to angle Q and angle F is equal to angle R. Therefore, by AA similarity, we can say that triangle DEF is similar to triangle PQR. Moving on to a third question. Diagonals AC and BD of trapezium ABCD with AB parallel to DC intersect each other at the point O. Using the similarity criterion for two triangles, show that OA by OC is equal to OB by OD. Now moving on to solution. Let us consider a trapezium ABCD with AB is perpendicular to DC and BD and AC be the diagonals intersecting at O. Then we are required to prove that OA by OC is equal to OB by OD. Now in order to prove that, let us consider the two triangles OAB and OCD. In these two triangles, angle AOB will be equal to angle DOC since they are vertically opposite angles. Those will be equal about the common intersection point. And also, as AB is parallel to DC, angle C will be equal to angle A. As they are alternate interior angles with AB parallel to DC and CA as transversal. Now again, angle D will be equal to angle B since they are also alternate interior angles when AB is parallel to DC and DB as transversal. Here, according to AA property, triangle AOB is similar to triangle COD. We know that when two triangles are similar, then their corresponding sides will be in proportion. So here we can say the corresponding sides, that is OA by OC, will be equal to OB by OD is equal to AB by CD. Here we need only the first two terms of proportionality, that is OA by OC is equal to OB by OD, which is the proof required for us. In figure 6.36, QR by QS is equal to QT by PR and angle 1 is equal to angle 2 show that triangle PQS is similar to triangle QTR. Now moving on to the solution. Let us note down the given information, that is QR by QS is equal to QT by PR and angle 1 is equal to angle 2. We are required to prove that triangle PQS is similar to triangle TQR. Now moving on to the procedure. If we consider in triangle PQR, angle 1 is equal to angle 2. We know that in triangle the sides opposite to equal angles will be equal. We can say PQ is equal to PR here. So let us replace the proportionality PR by PQ. Then we get QR by QS is equal to QT by PR. Replace it by PQ. Now if we consider this proportionality and compare it in triangle PQS and triangle TQR, now this can be written as, by cross multiplication, PQ by QS is equal to QT by QR. Now if we consider in triangle PQS and triangle QTR, PQ by QS is equal to QT by QR. So here two of the corresponding sides are in proportion, and also angle SQP is equal to angle RQT, which is a common angle in both the triangles. Angle SQP is equal to angle TQR, which is common angle in both the triangles. So finally, therefore, by SAS similarity we can say that triangle PQS is similar to triangle TQR. Moving on to fifth question. S and T are points on sides PR and QR of triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. Now moving on to solution. He says that there is a triangle PQR in which S is a point on PR, let it be here somewhere, and T is a point on QR. Now he says that angle P, which is nothing but angle QPR, is equal to angle RTS. So he has given that angle P is equal to angle RTS. Here angle P is nothing but angle QPR is equal to angle RTS. Now he asked us to prove the similarity between triangle RPQ and triangle RTS. So let us consider them. In these both triangles, angle QPR is equal to angle RTS, it is given. And in these both the triangles, angle PRQ is equal to angle TRS, since it is a common angle for both the triangles. Angle QRP is equal to angle SRT, since it is a common angle. So now by angle similarity, we can say triangle RPQ is similar to triangle RTS. This is what the required proof for us. Moving on to the sixth question. In figure 6.37, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. Now moving on to solution. He has given that triangle ABE is congruent to triangle ACD. We know that when two triangles are congruent, then their corresponding sides will be equal. So here AB is equal to AC and the corresponding sides, that is BE, is also equal to CD, and AE will be equal to AD. Now we are required to prove that triangle ADE is similar to triangle ABC. So let us consider in triangle ADE and triangle ABC, that is ADE is over here and ABC is a larger triangle. In this, angle DAE will be equal to angle BAC, that is this angle, which is a common angle for both the triangles. Now here let us consider the two equations, that is AB is equal to AC and AE is equal to AD. Now AE is equal to AD can be also written as AD is equal to AE, which implies, let us divide both the equations, then we get AB by AD is equal to AC by AE. So here if we observe clearly, the corresponding sides, that is AB in triangle ABC by AD in triangle ADE is equal to AC in triangle ABC by AE in triangle ADE. Therefore, here two corresponding sides in proportion and one of the angle is equal. So therefore by SAS similarity, we can say that triangle ADE is similar to triangle ABC. Moving on to the seventh question. In figure 6.38, altitudes AD and CE of triangle ABC intersect each other at point P. Show that in the first case, triangle AEP is similar to triangle CDP, and in the second case, triangle ABD is similar to triangle CBE. In the third case, triangle AEP is similar to triangle ADB, And in the fourth case, triangle PDC is similar to triangle BEC. Now moving on to solution. Let us first prove for the first case, that is triangle AEP is similar to triangle CDP. So in order to prove this, let us consider the both triangles, triangle AEP and triangle CDP. In the figure, triangle AEP is this and triangle CDP is this. In this, angle CDP is equal to angle AEP is equal to 90 degrees. As we know that CE is perpendicular to AB and AD is perpendicular to BC. And also angle CPD is equal to angle APE because they are vertically opposite angles about the common point P. So vertically opposite angles about the common point will be equal. So here we can equate angle CPD is equal to angle APE since they are vertically opposite angles. Now by AA similarity, as two corresponding angles in two triangles are equal, we can say triangle AEP is similar to triangle CDP. This is what our first proof we required. Now let us move on to the second bit. Here we need to prove that triangle ABD is similar to triangle CBE. So in order to prove this, let us consider both the triangles, that is triangle ABD and triangle CBE. Here if we observe the figure, the two triangles are triangle ABD and triangle CBE. So in this, if we consider angle ADB is equal to angle CEB is equal to 90 degrees, as CE is perpendicular to AB and AD is perpendicular to BC. And in this both the triangles, angle B is common, that is angle EBC is equal to angle ABD, since it is a common angle for both the triangles. Therefore, by AA similarity, as two corresponding angles in both the triangles are equal, we can say triangle ABD is similar to triangle CBE. Here in the third bit, we need to prove that triangle AEP is similar to triangle ADB. Now in order to prove this, let us consider both the triangles, that is triangle AEP in the figure and triangle ADB. In this, angle AEP is equal to angle ADB is equal to 90 degrees, as CE is perpendicular to AB and AD is perpendicular to BC. And also in both the triangles, angle A is common, that is angle PAE is equal to angle DAB, as it is a common angle in both the triangles. Therefore, by AA similarity, as two corresponding angles in both the triangles are equal, we can say triangle AEP is similar to triangle ADB. Now moving on to the fourth bit, we need to prove that triangle PDC is similar to triangle BEC. That is, triangle PDC is over here and triangle BEC which is over here. So in this, angle PDC is equal to angle BEC is equal to 90 degrees, as CE is perpendicular to AB and PD is perpendicular to CB. And also here in both the triangles, C will be the common angle. So here angle PCD is equal to angle ECB, since it is a common angle for both the triangles. Therefore, in both the triangles, two angles are equal. By AA similarity, we can say that both the triangles are similar. So triangle PDC is similar to triangle BEC. Moving on to the 8th question. E is a point on side AD, producer of a parallelogram ABCD, and BE intersects CD at F. Show that triangle ABE is similar to triangle CFB. Now moving on to solution. Let us consider a parallelogram ABCD in which BE is producer, AD is producer to somewhere, and from B line is drawn which intersects DC at F and intersects the extension of AD at E. So here E asked us to prove the similarity of ABE triangle, that is ABE, and CFB triangle. Here now, as he asked us to prove the similarity between triangle ABE and triangle CFB, let us consider both the triangles. That is, in triangle ABE and triangle CFB, that is, ABE is over here and CFB is over here. In this, angle A will be equal to angle C, as opposite angles in a parallelogram are equal. And if we consider that BC is parallel to AE and BE as transversal, then angle AEF will be equal to angle CBF, because they are alternate interior angles. That is, angle AEB is equal to angle CBF. So from 1 and 2, in both triangles ABE and CFB, the corresponding angles are equal. Therefore, by AA similarity, as two angles of two triangles are same, we can say triangle ABE is similar to triangle CFB. This is what the required proof for us. Moving on to the 9th question. In figure 6.39, ABC and AMP are two right angle triangles, right angled at B and M respectively. Prove that triangle ABC is similar to triangle AMP And second thing, CA by PA is equal to BC by MP. Now moving on to solution. Here in the first case, he asked us to prove that triangle ABC is similar to triangle AMP. So let us consider both the triangles. So in triangle ABC and triangle AMP, angle ABC is equal to angle AMP is equal to 90 degrees, as he has given that ABC and AMP are right angle triangles, right angle at B and M respectively. And second thing, angle CAB is equal to angle MAP, as it is common angle in both the triangles. Therefore, here as in both the triangles, two corresponding angles are equal, we can say by angle-angle similarity, triangle ABC is similar to triangle AMP. We know that this is our first proof. We know that when two triangles are similar, then corresponding sides will be in proportion. So here AB by AM is equal to BC by MP is equal to CA by PA. If we consider the last two terms of proportion, then we get CA by PA is equal to BC by MP. This is what our second proof required.